I like when it beeps. It doesn't beep at me anymore. Hopefully it's recording. And then in the rectangle, this would be your length. This would be your width. The reason we want to label those is since we're talking about a rectangle and we're talking about the area of a rectangle, then kind of recall old little geometry. You did a little bit of geometry in the day. You should know that the length multiplied by your width isn't that the area of a rectangle, or base times height. Okay, whichever you prefer. So this is a garden. I don't like thinking of a base if it's a flat surface on the ground. So we'll go with a length times a width. All right. So what we now need to do, the reason this is now just kind of the next thing we do after we've been solving these for about 2 weeks is we just now need to come up with our equation. It's the only thing that's different. Once we come up with our equation, then we need to work our way through, solve the problem. Okay. So with this, we don't want these to be two different variables. So when you would have started word problems, whenever you would have did those, however many years ago, little word problems, your teacher would have told you to define your variables. So the variables we want to define are our length and our width. If we go back to this sentence right here, it says the length of the garden needs to be 8 feet longer than it is wide. So whatever I let the width be, the length needs to be 8 feet longer. So the way we're going to approach that, we're going to make our width be x. All right, that's how we're going to define our variable. And then again, if we read this sentence right here, the length of the garden needs to be 8 feet longer than it is wide. You could. Totally fine. I like using X, so that's what everybody uses. But we could definitely so here's Henry's question. Can we just let W be W? That's fine. If we do it that way, I'm going to use X's. I just like X's and people are more familiar with them. Then I would take wouldn't my length be whatever W is, and the length has to be how much bigger than the width? 8 feet. And then you would just add 8 to this. Okay? So if you want to use W's, 100% fine. If we want to use X's, because that's typically what we're using, just let your W be the X and your length be X plus an 8. Exact same thing. So whatever your preference is, I don't care. Okay. Then we come over here. We're going to multiply these together. So we're going to multiply these two expressions together. So my length is X plus 8. I'm going to multiply that by my width, which is an X. We're going to set that equal to the area. We know what our area is. It's right here. It's told to us. The area is 48 feet squared. So we're going to set that equal to 48. And that's our equation. That's what we need to solve. Now, it's been 72 hours since you've had to do one of these, but when we solved all of these, link down here to number 3. I promise if I passed your quiz back, if I had gotten it graded, that every one of those was set equal to a 0. If it's set equal to 0, you can factor it. You can do the quadratic formula. You can do that square root method. We want to get this set equal to 0. We also want it in this order. We want our square term, our x to the first term, and then our constant. So if we look at this, there's some work for us to do to get it in that format. So the first thing you're going to do is we're going to distribute. You're going to take your x and you're going to distribute it to the x and the 8. So x times x is x squared, or if you like the w's, you would have w squared. And you're going to do x times 8. That's just an 8x. And then that equals 48. So when we talk about standard form, the form we like it to be in, we've got these two taken care of. We have the x squared term. We have the x to the first term, but we still don't have the 0. So we still need to create that 0 on the right-hand side. So if you go back to this problem, if I want that right-hand side to be 0, I'm going to subtract 48. Because then that nicely gives us the 0 that we're looking for on the right-hand side. Bless you, Destiny. I like the hair. I almost did that to mine this weekend. Nice. That would have been awkward. I know. If you next time. I like it. It's cool. I like it. You're vibing it. Good. All right. Whatever I did the one side, though, don't we have to do the exact same thing to the other side? So if I subtracted 48 on the right to get that 0, I need to subtract 48 from the left. Notice, these are all not like terms. This is a square term. This is an x to the first term. This doesn't have any x's. So we can't lump any of those together. And we want to put it into this order. We want the x squared first, the x to the first second, and the number last. So when we rewrite this now on the left-hand side, we're going to put this as x squared plus an 8x minus a 48, and then that's going to equal 0. Well, we introduced it very briefly last week. We're going to introduce it a little bit more today, and that's really going to be the crux of what we do tomorrow. We now have three options here to solve this. Our three options, the first option we did is factoring. The second option we did is with the square roots. That's when we started getting all those plus minuses. And the third option is what you did on Friday, and that's the quadratic formula. So you could really use any of these three to solve this question right now. To me, and I think for most people, factoring is the shortest, most efficient, easiest way if it factors. So this is the way that we're going to try to do all of them. And if not, then we've got to explore these other options. All right. So if I go to factor it, this is our oldest one. This is when I would always ask you initially, what numbers multiply to be a negative 48 and at the same time would add up to be a positive 8. All right, find those because this does factor. So go ahead and factor that. See if we can come up with those. Okay, anybody feeling clever early Monday morning? Got those? One.
-4 and 12.
Good. He said -4 and a positive 12. So if we check, -4 times 12 is a negative 48. And then the -4 plus 12 would add up to be a positive 8. Then what I would do when we did these, I would then ask what factor makes this one a 0? Maria, that would be x equals what?
Positive.
Good. Positive 4. And then Mark, what factor would make this one equal 0? Good. Negative 12. And then those would have been our answers. With this, though, there is one extra thing you need to consider. What we are talking about is the length of a garden, right? The width and length of a garden. Is it possible to have a width or length that is a negative length? No, we can't have a negative height. We can't have a negative length. We can't have a negative width. So even though the algebra here gives us two different answers, you would not consider this a viable answer if we're now dealing with this kind of little life problem here where you can't have a negative length or a negative width. So x equals 4 is the one we want to go with, but answer the question as well. What dimensions? So what's our width? What's our length? So our width, isn't our width just whatever we found x to be? And our x is a 4. So that is, my pen will work, 4 feet. So our width is 4 feet. And then our length, one of two ways you can get this. The whole premise of the problem is we wanted our length to be 8 feet longer than the width. So if you just understand that, doesn't that have to be 12 feet? Or you can plug it in right here. Just let the x be the 4 in the length that we defined. And that 4 plus 8 would also give you the 12. All right. So in terms of what we would want to do, this would be the dimensions that we would want to use for that garden. Okay. And since factoring worked, we didn't have to worry about square roots. And we didn't have to worry about the quadratic formula. All right. With that, go to number 2. Let's get it set up. And then I want to see one part, see if we can do this on our own. So now we have Clarita. Her garden needs to be 13 feet longer than it is wide. So again, let's sketch in a rectangle. This is your length. This is your width. The overall area that it's covering up is 48 feet squared. And in this case, well, let's start with this. Our length times our width will give us our area. That's the area of a rectangle you've known for many years now. We know what the area is. That's given to us right here. So we're going to put 48 on the right-hand side. But we don't have our length and width defined. So off to the side here. So now it's up to you. Henry might use W for W. We might use an X. See if we understood how we define these here. So get those two variables. You know what time we get out of this period?
I don't think so.
6. Okay. All right, Henry, how'd you define them?
How did I define?
No.
I put W is X.
W is X? Okay, good. So W is our X, and that means our length, if it's 13 feet longer than this, would be written how?
X plus 13.
Good. Whatever the width was, we need to have 13 feet longer for the length. Okay? The reason that's now nice, come over here, we have these two. So our length, Henry gave us as X plus 13. We're going to multiply that by the width. We said our width is the X. Now it's the point of making it in that form that we want it to be in. Just like we did above, we want it to look like this right here. We want it to be X squared, and then your X, then your number, all set equal to 0. So we now need to go through the steps to make that happen. So that will first, similar steps to last time, you're going to distribute. So X times X gives us the X squared. The X times a 13 gives us 13X, and then all of that equals 48. Then we're on our way a little bit. We really want the right-hand side to be a 0. So to make that happen, subtract the 48 over. And then we get the 0 like we want. But then write it in the correct order. We want X squared first, then your 13X, and then the constant last. All right. So again, if you really like the quadratic formula, you can do the quadratic formula right now. That's what we quizzed on. We haven't talked about this too much recently. We're going to do one of those here later. But again, if you can factor, that is definitely the quickest, simplest way. This one does factor. So factor this for me. Not quite as obvious as some that we've done, but what numbers multiply to be a negative 48 and would add up to be 13? They do exist, I promise. If you have your factor chart, you could use those. Calculator. If you're just clever like Diana, you just do it right in your head. Right, Diana?
Yeah.
What do you got, Diana?
It's the two numbers that have to be 13 and multiplying for you.
Correct.
8 and 6.
All right, let's try it. Positive 8. And then what'd you say? All right, so if I did a positive 8.
No. Wait. Negative and negative. Right?
Well, let's do this.
Wait.
So 8 and negative 6 satisfies that. It is going to give us a negative 48. But when I add an 8 and a negative 6, will it give us that 13? Yeah, even if we tried that, so if they both are negative, we have a couple issues now. Wouldn't this give us a positive 48? Yeah. So no combination of 8 and 6 are going to work. And those are probably the one that are most obvious that we're going to think of right away. But those won't work. Sarah, what did you come up with? All right, so let's try positive. What is going on with these pens? Positive 16. And then what did you say? Negative 3. All right. Doesn't 16 and negative 3 give us a negative 48? Yeah, it's not one that's quite as obvious if you throw it into your calculator. I promise it does. And if I add those, do they add up to be 13? Yeah. All right, so good. Those are our two factors. And then, like I said before, this is now when we identify what makes this factor 0. What would that be, Sarah? It's first one. Good. Negative 16. And then what makes this factor a 0? 3. Before today, both of those are your answers. Today, we're talking about the length of a garden. We cannot have a negative length. All right. So with this, we're not going to include this as part of our answers. The X value of 3 is part of your answer. That's going to be your width over here. So my width is the 3. And then notice what we have to do for your length. You're going to take what we just found our length to be, or width to be, which is 3, and then increase that by 13. So my length should be 16. And then those are feet. 3 feet by 16 feet. And then we're all good. All right. So largely the same stuff, a little bit extra detail. We got to come up with the equation ourselves. But nothing real new here. What I want you to do next, while we just did the 2-word problems here, go down to number 5. Don't worry about it saying using all 3 methods. Just set this up, see if we can go through this. I promise it factors, and see if we can solve this one. So 3rd one now, see if we're following the process that we just did back to back, and see how far you can get. It's the last little word problem of this, and then we'll go in a somewhat different direction. That's what was here. Now, next step. And then again, both of those answers don't work. What we ultimately want are our length and our width, so make sure you finish it off entirely. Okay, most of us are on the right path here. There's a lot of steps, a lot of little places to make a little mistake along the way, but same idea. You have this rectangle. We're given the area of the rectangle. That's why we're using the whole length times width, because that's how you find the area of a rectangle. So length times width equals your A, and then the A we know is 16. That was given. We have to define these guys. So similar to other ones we've done before, if I let W be the X, I know that the length has to be that value increased by 6. The length has to be 6 longer than the width. Okay. That then allows us to substitute in the length for X plus 6, and then the width for X. And for the most part, walking around, we had that down pretty good. All right. Now we need to clean this up, make it look like it's supposed to look, put it into that standard form. So X times X is the X squared plus a 6X. All right, and that's just us distributing the X everywhere. Out of there. We now want this to be a 0 on the right-hand side. So to make that 0, we'd subtract the 16 away. There's our 0. But we have to do the same exact thing to the other side. These, again, are not like terms. None of these can be grouped together and combined. So then we just write them out in the correct order. X squared plus a 6X. And then minus that 16. And then this does factor, so we don't have to worry about the other two longer methods. Heilman, what'd you come up with there?
-2, +8.
Good. X minus a 2, and then an x plus an 8. Those multiply to give you a negative 16. When you add these up, they'll add up to be a 6. All right, and then Diana, what makes this factor a 0? Diana, what makes this factor a 0?
2.
Good. 2. And Amarian, what makes this one a 0? All right, but which one is our answer, Amar? At least kind of our answer, Amarian? Good. Cannot have a negative length, so we're going to say that that isn't possible for the context of this problem. But then ultimately our answer is, what is our width? What is our length? We don't just say x equals 2 as our final answer. So if I ask you for your width is whatever x is. So whatever we get for x, that is your width. That is our 2. And in this case, that's feet. And then your length is whatever we get for x increased by 2. So if x is a 2, or by 6, if x is a 2, add 6 to that, that should be 8 feet. All right. Did we get through that all the way? Good. All right. So when we do the little word problems, it's just basically the same thing we've been doing. It just makes you set up your own equation. All right. All right. 2 more I want you to see here, hopefully. When we get 6, you said?
Yeah.
Go to number 3. And then you're going to see these directions. I do want to do all of these real quick. So the directions to number 3 say solve these problems using all 3 methods. The first method is factoring. So for number 3, why is this not? Solve that by factoring. Try to conserve some space. There's going to be a lot of work here. So let's put factoring, write the word here, and then let's do that right underneath it. This should be really, really, really easy because we've already done it today. It's one of the 3 problems we've already factored. So factor that real quick. The 2 numbers that multiply to be a negative 48, but when we add them up, it's going to give you a positive 8. What do you, Riley?
X equals -4.
Before that step. So x what in these guys? Good. And then x what?
+12.
All right. So positive 12, negative 4, multiply those, give you the negative 48. When we add them, you're going to get a positive 8. All right. So then Mirna, what solves this one here? What's going to give us a 0 here? Good. Positive 4. And then the second one, Mirna? Good. Both of those are your answers now. This isn't a word problem that's representing the length of a rectangle. So there's no reason for us to cancel out any of them. Those are both your answers. To me, that's the easiest route. So when we say your 3 methods, I think that's the quickest, easiest way, if it happens, if it can happen. The second way we're going to do it, the second way I'd like you to do this in this order, do the quadratic formula, because that's what we quizzed on Friday. So we should be pretty good with the quadratic formula still. Hopefully. I'll find out soon enough when I grade your quizzes. So go ahead and now use the quadratic formula. I don't want to write it down. We've already quizzed on it. We hopefully have it memorized. We know where we get the A, the B, and the C from. So do those first handful of steps. And if you're confident, just continue on. We know what the answers are. You better get for negative 12 again. All right, just a different way of doing it.
or is that-
Also, just as a heads up, we mentioned this a little bit and start to see it more and more. We were able to factor this, so this does work. Factoring works. So that means, even though it's going to be a pretty big number, the number you get underneath this radical right here should be a perfect square. It should be a nice perfect square. We shouldn't be getting these weird radicals that we're splitting up and trying to break down. This gives us a nice number. It's bigger than it's probably a perfect square you're not familiar with, but it is a perfect square. If you're wrapping up, we know our answers. They're 4, -12. You better get the same exact answers you get right here. All right, if you don't, then obviously you're wrong. If you do, you know you're right. Okay, let's go ahead and go through this. So here's our equation. Negative b plus or minus the square root of b squared minus 4 times a times c, all over twice the a. So when we now clean this up, what I was talking about, this nice perfect square, underneath this radical, so this should be 64. Be careful here. I'll be curious how many people we made this little mistake here on our quiz Friday. This is a -4 times a 1, and then that multiplied by a -48. So a negative multiplied by a negative should be positive, and then that all multiplied out should give you 192, and then all over 2. So this then has to be a nice perfect square. So when I add these up, the 64 and the 192, 256. So first period, people were starting to break that down. They're trying to figure out nice perfect squares that give us 256, when in reality, this is a perfect square. So if you just went into your calculator and type in the square root of 256, what was it? 16. All right, the square root of 256 is 16, not square root of 16, just a 16. All that gets divided by 2. This is now when we can set up our two different equations. So one equation is going to be me taking the -8 and doing a positive 16 and dividing by 2. The other one is going to be the -8 subtracting 16 and dividing by 2. Better give us 4, -12. So the first one, -8 and 16 give us 8. Divide that by 2. There's the 4 that we knew we were supposed to get. -8 minus 16 is a -24. Divide that by 2. And then that gives us the -12 that we were supposed to get. So again, go back to our first method over here. Isn't that the same exact thing we got that way? Yeah, just a different route. Okay. So kind of in that order, I think factoring is the easiest. I think quadratic formula is the next best option. And then what I think is the third best option and final option, at least for what we would do with these. So you do want to do it here. We have quiz on this. This is the little square root idea, the perfect square, square roots, all of that fun stuff. All right, so write that, and then hopefully you still have some room in here. Rewrite the equation. And this is our third option. This is the first one that we started with, or not the first one, the one we did right before the quadratic formula. But this is when we would take that x squared plus 8x, and then I would leave a space here to make a perfect square. And then we'd leave the -48 behind. If you still want to draw the square, that's totally fine. So we would draw this little square out, and we know we have x squared right here. And we would then know if this is an 8x, darn it. If that's an 8x, half of them go right here, half of them went right there. So I had 4x and 4x. So doesn't this become a perfect square if I have a 16 in this bottom right-hand corner? So if I add 16, that makes this a perfect square. But if I now add 16, that wasn't part of the original problem. We need to subtract 16 from the negative 48. Then this x squared plus 8x plus 16. Notice we had an x and a 4. That's where these would have come from. This was an x and a 4. So I have x plus 4 2 times. Negative 48 minus 16 is a negative 64. And then that equals 0. Then what we talked about with these, we always wanted to get the squared term isolated. We want this to be by itself. So in order for us to do that, we actually want to move that negative 64 over. So I'm going to add 64. The x plus 4 squared is now isolated like we want it to be, and then that equals 64. Real quick, do the next step here. See if you remember what we did at this step. So what do we do next? We're trying to solve for x. What's our next step? All right. Hannah, what'd you do? Oh, man. Anybody want to raise their hand and tell me what they did? Juan, what do you got? I'm not that one.
Yeah.
Yusuf.
Squared, x squared, the rectangle, and then the 64.
Good. So if we want to get rid of that squared, he said squared. I think you did this, right?
Yeah.
So square root. So we took the square root to get rid of the squared. So that means I got to do the square root of the right-hand side as well. The square root and the square cancel. All we're left with is x plus 4. This is when we were first introduced to the idea that when I take that square root, it's the first time we really talked about this little plus minus sign. So yeah, that's an 8, but it's a positive 8 and a negative 8. That's when we first started writing the little plus minus. That's also where we first started writing two different equations. So one equation was when we took x plus 4 and set it equal to the positive 8. And then the other equation is when we took the x plus 4, set it equal to the negative 8. Solve each of these. So subtract 4 from both sides. 8 minus 4, there's that 4 again, like we knew we were supposed to get. The other answer better be a negative 12. And when we subtract 4 from both sides, you're going to get the negative 12. Okay. Now, long term, you're going to be able to choose. Actually, tomorrow, that's kind of what we're going to get into a little bit tomorrow, is which one is the best. The last one I want to see, go to the very last problem. We're not going to go all the way through it. We don't have time. The question doesn't even really ask you to go all the way through it. The question is asking you to determine which two best methods allow us to solve this equation. So again, it's asking us which of these are the two we would like to use. Do we want to factor? So factoring. Do we want to use the quadratic formula? Or do we want to use square roots? I have said multiple times, I think factoring is the easiest. It's the quickest. So do that real quick. That's the easiest, most efficient, the quickest. That should be everybody's first option. So find two numbers that multiply to be a negative 16 and then add up to be a 10. Anybody got those? Sage? Got them?
Well, I mean, I would think 8 and 2, but that doesn't make a negative 16.
What if we did a positive 8 and a negative 2? That gives us a negative 16, right? So do these multiply to give us a negative 16?
Yeah,
Do they add up to be 10?
no.
No. So that doesn't work. What she said is if I did 8 and 2, don't 8 and 2 add up to be 10? But do they multiply to be a negative 16? No. Anybody come up with a combo that works? Good, because this does not factor. Okay? So what that then means is, while this is the easiest, quickest, nicest way to do it, if it's possible, we have encountered a few, we're encountering one right now where this doesn't factor. That means you are then kind of stuck either doing the quadratic formula that we quizzed on Friday or doing the square root method that we quizzed on the previous Friday. Okay? And that's sort of what we'll get into. We don't have time to go through all of those. That's what we get into a little bit tomorrow. Eventually, you'll just, here's this method, pick whichever method you want to use. Negative 16 and what? Oh, those are the final answers? I'll look at it, but it can't be right. It won't be that. And the reason I know that, if it doesn't factor,
Yeah.
that means you're going to get the other square root.
Oh my God. Rolling.
What is it?
My savior.